we go. Stream manager. Okay, cool. So yeah, the first thing, as I was saying, was we're gonna have to look at enabling the NVMe in QEMU. And then we'll work on trying to understand the steps we need to initialize the NVMe, or at least start communicating with it in this initialization routine. I'm hoping we can probably get to doing these checks. Start the controller, enabling interrupts and registering a handler. Interestingly, we have to handle its circular buffers head and tail. I read somewhere. Delete queues, wait, submitting a command, IQ handler, yeah, okay. Cool. I'm going to start by seeing if I can get QEMU up and running with the actual driver. So what I did last night was I fixed the HDD compilation of the kernel, and that appears to be running absolutely fine. So if we can just, I'm probably going to ask ChatGPT for this. See if it can just give me the flags I need. Let's see. So, what are the flags for enabling? So it's a device option. Another video about June. Cute dog. Huh? What? Cute dog? What are you talking about, dude? See if I can get this into our build config and then check our... Oh, you're stuck in a commercial? An ad? Dude, that sucks. I mean, you know, if subs get ad-free viewing. Just out of curiosity, Fly, what is the cost for a sub for you? Because when I sub to some people, I've not looked at the price, but it's quite cheap for me. It's like £3.99p. $45. Yeah, sure. Let's turn this down a little. Oh, it's $4.99. Cool. Dude, you subbed. What a sucker. Now I'm gonna have to buy you Steam games. Your balance is at $4.99. So next time there's a game on sale, I have an excuse to buy you one now. So it's kind of like reverse guilt. Guilting you into subbing guilts me into buying you games on Steam. That's how it works. Thanks, dude. But yeah, let me know if that fixes your ad problem. Alright, so we're gonna start running with the HDD setup. I wonder if the UEFI one works then. Oh wow. So the UEFI one works. It gives me the XSDT table, which I've detected and said, hey, I'm not supporting this. But I should do, really. It's not a problem. I'm not sure what that gives me, though. Like, what's the point of running with UEFI? So what I'm going to do is I'm going to make this run ISO. And then I'm going to make run HDD the standard run command. Yeah, so that's calling for the image HDD, and that's now running with the hard disk. But our log output, actually, you know what I'm going to do? Before we do this, to make it easier, I need to convert the PCI scanning to strings. And I at least just want to pick on these devices that we found for now. What we're going to do, so we're ultimately trying to get to the point of where we can read from the hard disk. But we're going to make it so that the hard disk in the emulator is set to be an SSD. And SSD drives use a controller interface called the NVMe. And it's a really, really fast way of accessing disks. So from what I've learned in the documents, the reason it's super fast is because you can queue up thousands of requests at once, and the disk, like the SSD, can fetch all of that information for you at once, which is how they get high throughput. So, you know, when you see an SSD and it's got like, you know, 500 meg per second read, I'm assuming because it's got this massive high bandwidth of requests that it's chewing on at once. Like, I don't think you're sending to it like read me a 512 meg chunk, you know, per request. I think it just supports many requests at once. Highly concurrent. So it's got quite a lot of ceremony to setting it up. It's a bit scary, but I'm going to try and do everything super minimal and see where that gets us. So let's do this nice little task just to warm up and get the strings in from the subclass codes. So it'll be, let's see, be under PCI, and this will be under the class codes here. And then I'm just going to do a class and subclass. The prog if. Should I do the prog if as well? I guess I could. But yeah, before you got here, we were talking about how complex the NVMe controller is. But I'm kind of using the wrong word. I don't think it's complex. I think it's just very verbose. Like the concepts it has is like it's got some queues, it's got a circular buffer of commands. So yeah. But yeah, I'm going to take, so let me put that over on the other side. I am going to, these are the IDs that the PCI devices that we've found in the system. Now, another thing we can do here too is not only just the string representation of the devices, but we can start to bring this information that we've scanned for, and we can store that in a structure array, like a list, you know? Because at some point we're going to want to show the user that these are the device, like the device tree that's connected on your machine, and eventually write drivers for each one of these devices that we've found on the PCI bus. But yeah, for now, in terms of drivers, we'll just target writing the storage device. I'm going to grab those and I'm going to create a helper function for these. Let's see. Get device str maybe. And it's the class code. It's a subclass code. And prog. Which I still don't know what it stands for. Yeah, I've got a feeling this is going to be one of many streams to get this up and running. Like it feels like it's a bit of a long haul into seeing some good results from this controller. Because like the ultimate result that we want from it is to be able to read data off the disk. Like maybe just reading the a big memory dump off the disk and seeing if we can find the kernel data, for example. GPT-5 news hasn't been released, has it? Oh, Llama 3 from Meta due in July. But GPT-5 might be out before then. Cool. All right, let's get these class codes rocking. So these devices, and I'm probably just going to do something really crude. I'm not going to create a fancy map or anything. So like we can do, let's do 6 first. Well, that's the bridge. 3 is the display controller. Yes, we can do a switch on the frog. Seeing if I can remember what the syntax is for a switch statement in C. So what's 3? The display controller, and we get 300. So this will be display controller. VGA compatible controller and it's kind of weird to see that. The device is a register level programming interface. Oh, that's what that means. In that case, I'm going to just do that one. Why is it complaining? Not too many. There we go. Uh, 3. Let's do. Should we do a switch in the class code as well? So then I can do. So what's 00? We don't have 00. We're going to do 1, 6. So what is our 1, 6? That is a mass storage controller, and 6 is a serial ATA controller. Yep, 3 and 0. So that one's done. That one's done. Guess we could do 2. 2 and 0. Network controller. And this is a Ethernet controller. Da, 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 da. Just put a link in there to those class codes. Anyone who's wondering where I'm getting those codes from. That's 2 and 0. We'll do 6, 0, and 6, 1. Do a default return for unknown device. So classification 6 is a bridge. And bridge 0 is a host bridge. Bridge 1 is an ISA bridge. All right. Six, 1, and 6, 0 completed, and then we'll do 12, 5. Twelve, 5, which is OC. I'm not sure what this is. Serial bus controller. And then it's this SMB bus controller. Okay, now we can kind of get the device string representation of the specified class and subclass code. And then what we can do is now call this when we dump that information down here. I'm just going to dump it here, I think. Just get rid of my BattleNet. It's going to be pinging all night because my friends are logging on to games. Finished work and they're off gaming. Okay, and then we'll call that function get device link, which is our class code and subclass code. Progif won't get used now, but we will save it. And it's complaining about my lack of break statements, perhaps. Does it really want me to do this for everyone? It did. All right, so let's see if that cleans up the log. Hey, what's up, exploding? Yeah, I'm definitely having some fun for the moment, but we're definitely going to get into trouble soon. Definitely going to have a harder time riding the next driver. But there's only one way up the mountain, I'm afraid. All right, so we've got textual representations here now. So we've got the host bridge, the display controller, the network controller, the bridge, the mass storage, the serial bus. And now I want to know if we switch to NVMe setup, we should get an unknown device and then we can plug that in. So back to ChatGPT where it gave me that flag. All right, let's try and plug this in. Let's bring this guy to the top because that's the first one. Oh, I do have a clean. I didn't think I had a clean. HDA. Right, I just need to find out what this... just accidentally closed my chat. 1 second. And we're back. So I just need to grab the QEMU docs. Make sure I'm not conflicting flags. So HDA are essentially macros which expand into drive options for various drive interfaces. The original forms bake in a lot of assumptions from the days when QEMU was emulating a legacy PC. They are not recommended for modern configurations. Wow, okay. Now then, if I do specify, so let me grab flags that we want to add. I am going to ask it to convert what we have. So device F9 my drive format raw. Okay, so we need to first connect the device manually like this. Should I say connect the drive, but then enable the drive device as NVMe here. Serial number drive, my drive matches that ID. ID is NVMO. Do we need this numQs4? Guess I could add that. See if it. That's probably the max queues that it supports. Pull that up on the screen. Yeah. And then, yeah, let's see if that now, that should give us a log saying that it's found that device if it's on the PCI bus. And we're not handling it with the device string, so we should get a nice device not found, which we do. We've got an unknown device. Oh, I should have dumped. Oop. Dump the codes, class code. Man, IntelliSense sucks in VS Code. It gets lost and confused so fast. I did try to give JetBrains' C and C++ IDE a spin today, but that is very heavy. What are the applications of writing your own kernel in the industry? Robotics. There are people now writing kernels for AI. So OpenAI are looking to create a new AI chip, and that will require its own kernel. I doubt they'll get Linux to support that. They'll probably just write a dedicated kernel for it. But yeah, I think most, from what I can gather from like the NVIDIA CEO, is that NVIDIA attempted specific chips with very specific purposes in the past, and they don't do very well at all. And they found that just creating general purpose chips with general purpose kernels is way more easier to produce and support. So they've casted doubt on OpenAI's desire to make an AI specific chip. But OpenAI, I don't know if you've heard, they're asking for like trillions of dollars to start that chip development. And I've not heard whether it's going to go ahead or not, but NVIDIA have said like, don't do that. It's going to flop. But there are already AI companies in America that have written their own operating systems for their own robots for AI purposes. So, like the Rabbit OS device, I think this is. I think this has a custom OS. Not heard anybody talk about Rabbit OS. I'm just making a big assumption there. But yeah, so basically, whenever somebody comes out with a certain custom kind of motherboard or electronics chips, um, you need a kernel to connect with that chip setup. Like a Linux kernel might start up and be looking for things like the ACPI and the LPICs and stuff like that, and assume that it's running on a BIOS or UEFI. And if you put it on a system that doesn't have a BIOS or doesn't have, an instruction set like x86, then it'll just fail right out the gate. But saying that, Linux has an insane amount of support for different CPUs. Like if you can look at its folder structure and look at all the CPU names, and there's stuff that from decades, 20, 30 years ago, it's got like 50 different types of CPUs that it can support and run on. Like when you hear Linux runs anywhere, like it runs on TVs and microwaves and washing machines, and I think it has all of that. I think they've sniffed out in the industry what all those different processors look like and made Linux a very general purpose supporting kernel. Which, how I think about that in my mind, it must be a very large kernel. Like, I wonder how much conditional compilation it has, knowing what kind of CPU it's building for, like the architecture it's building for, what drivers to strip out, and what parts of the chipset to strip out. I'm assuming it would do. It would be silly to just build everything and package everything into one big kernel build. It's actually really fun walking into the Linux source code and poking around in there. So like the folders all look like where you'd expect. Like when I've looked at other operating systems, all their folder structure looks very similar. Like is their memory manager, kernel stuff, the file system. Um, that's all their drivers. So, we've only got one driver at the moment, which is PCI, sorry, PS2. Uh, but this is their directory of drivers that they've written. Um, so even the HPET, I think, is in here. It might not be in drivers though, because it's not really a thing that has a driver, but it definitely has a HPET somewhere. Anyway, you start in the Arch folder, and this is the architecture, the processor architecture. So for example, you've got x86 down here, which are Intel and AMD CPUs, and then you've got all these different kinds of architecture CPUs. So you've got ARM. I don't know what these are. I've never heard of Microblaze, MIPS, OpenRISC, PowerPC, Spark. So these are the different architecture chips that it supports. But yeah, it's nice to kind of poke in here. It's not that overwhelming once you know how to get around. What's really overwhelming about the Linux code base in general is because, for example, when they write a PCI driver, So we've wrote PCI, right? Let me give you an example of why it's insane writing your own OS properly. So this is a PCI driver, and it's currently 197 lines, and it's really brute force and really like hello world. But um, the Linux PCI driver will be so specific to supporting every kind of motherboard it's ever seen. So every motherboard that anybody's ever tried to run Linux on, there's probably something like a bit of a nuance to do with that motherboard, and it acts a little bit differently to somebody else's. And there's bugs around the chipset that the way you treat it. So when you open up their drivers, it's got tons of comments around specific things that they found with particular motherboard setups and the bug fixes that they've had to do to get around those specific problems that they found on specific chipsets. So um, yeah, so you have to kind of be careful sometimes coming in. See if they've got the HPT, for example. So yeah, it's in. So this is the high performance timer, and they've written this in 1,000 lines of code compared with mine. So if I go HPTC, I've got 255 lines. So they've covered way more about that particular configuration of the high performance timer. Um, and these comments that you find are just, they're golden, really. Like, if you really want to write stuff properly to run on lots of different hardware, then you're going to want to do it to this kind of degree. But it's kind of overwhelming to do that. So I'm kind of happy to support QMU at the moment. So yeah, I mean, Linux is like the ultimate documentation where you would look for finding out how to properly implement your drivers so it's bulletproof for lots of different motherboard setups. CD-ROM drivers. Look at this. Oh my god, this is nearly 4,000 lines of code. The CD-ROM? Holy moly. Like, that's a lot of code. Like, just think about how much learning if you're going to write that from scratch, reading from specs, and you, there's tons of different brands of CD-ROMs and stuff like that, or used to be. So I imagine they just went through so many different manufacturer types and supported them all. ISO 9660 is not easy. Is that what CD-ROMs were on? But yeah, so the one we're doing now, I think this is the biggest kind of proper driver that we're creating, which is the NVMe stuff. So let's just go and have a look of what maybe they've done. It looks like it's split across multiple files though. IO control. Let's try this one. So this IO control file is 900 lines of code. And again, we're probably not going to get anywhere near this. It also covered DVD and Blu-ray. Oh, I see. That makes more sense then. I think yeah, Windows exposes all those kind of drivers as a generic, what do they call it? An ATAPI driver in Windows. It was always known as the ATAPI CD-ROM driver. But yeah, so um, there was a nice person on Discord in the OS Dev community. I don't know if he watches the stream or not, but he might have been watching the VODs and he heard that we were getting into NVMe. And that crazy ass guy is so hardcore that his 64-bit OS is written in pure assembly. And he's already written NVMe for his 64-bit assembly OS and got to the point of being able to read hard disks. And he's offered his help if I get stuck. Because he's finding a lot of value from some of the code that I've written around the IO APIC and the HPT timer. Which, if you think about it, it's crazy, right? Like, things that I've been taking my knowledge from is like all the OS Dev Wiki, and Lyra OS has been a big inspiration in me finding stuff and seeing how stuff is laid out. And that's gone now into Blur OS, and then people are reading from Blur OS and making stuff, taking code from that and putting it in their OS. Which my emphasis for Blur OS, I think, is more educational. Like the whole purpose of writing this OS is to get a feel for what a kernel development process is like. And with the intentional hope that we can produce some content on YouTube of going from day one and showing people how you would start writing your own kernel. Oh, right, yeah, there were SCSI drives, there was IDE connectors, there was SATA. 128-bit OS. Dude, what is the max value of 128-bit? Like, how much? That is a bit of a leap. I mean, 64-bit OS is, I think, in memory addressing, it doesn't even use the full 64-bit. I think it's only like 50 something bits. So it doesn't even need that much address. But 128-bit would be silly. Anyway, coming back from that little history tour of the Linux, let's try and plug in this NVMe device. So we're looking for that code dump. Let's just rebuild and run. See if we can get those codes going. Wait, didn't I? Oh, I think I know what's happening. We are probably not getting down to that line. We're probably what a shitty way to implement a string lookup of your device. But it works. Okay, so it's a 1 and 8. So 1 and 8 is a mass storage controller. So just slot that guy in here. And that is, so look, the non-volatile, as it's called. All right, there we go. We capture it now. So we've enabled NVMe on the QEMU boot. So that line there is putting the NVMe controller onto the board for us to interface with. Never say never. Bill Gates said 64K would be all we need here, I guess. If you consider, I don't know, the amount of data that AI large language models churn through, we might get to a point there where it wouldn't surprise me. Would a different CD-ROM drive also potentially change how data is actually written on the disk? If you put in another machine, it wouldn't work. You mean the disk that? Do you mean the device, or do you mean the actual CD-ROM? No, I think CDs are DVD drives and Blu-ray drives have been phased out. You can probably obviously still buy them because of people's Blu-ray collection and DVD collections. But yeah, there's no way those come in builds anymore. Da, da, da. Still use CD, DVDs, and Blu-ray. It makes me nervous not having one, but that was only because years ago I would probably experience Windows crashing and have to reinstall Windows a lot more, which hardly ever happens now. Age of Empires 2, dude, those original Age of Empire games were amazing. I'm so glad you're all chatting today because I am procrastinating like crazy. The the start of this NVMe is scary. Quarter-inch disk drives? Dude. Um, right, we're going to just do a bit of configgy stuff. So I'm going to create a structure for capturing these PCI devices, and then I'm going to start trying to parse that NVMe address. So let's begin with a structure in here. We'll call it a PCI device. Okay, and then we'll do prog interface. I guess we can do the description. Why not? It's a static piece of text that we've stored in the kernel, so we may as well. What else do we need? Oh, we need the function and the bus number. We want bus and we want the function. And then we'll have, let's see, um, so that'll be an array of PCI pointers, and then we'll have to do a device count just to assist in parsing that array. It's not that I didn't have old tech, it's just that when I moved, I threw everything out that I don't use anymore. I was quite stringent in not hoarding stuff because it kind of grossed me out in how much stuff I used to have. Like rooms full of tech and old crap. So I just threw it all away. Yes, call you a hoarder. I mean, if I really wanted it, I'll just order old stuff off eBay, right? Um, okay, let's grab these. Let's put them in the PCIC file. Um, let's create 32 devices max. That's another thing too. At some point, we're going to want to develop the memory manager to help us allocate memory. Like we need to get a vector type, a resizable array. So I need, not only do I need a malloc and free, but I need a re-alloc when I want to resize buffers, just to help me assist me in little things like this. But I'm kind of cheating here and just being like, oh, okay, 32 devices max. And then if we go over that, we're kind of screwed. But it gets us over storing the structs. Um, yeah, actually, we are going to need to allocate memory here. Oh, we've got, sorry, yeah, we've got mem. So when we get device string, check function, where are you? So when we grab all of this stuff here, um, can it tell me what the size is? 16 UL. When it gets over 30, dude, well past 30. These armrests on this chair kind of ache my shoulders after a while. Need a new chair. Okay, so we're allocating some memory for the new device struct. We are going to do we need to initialize the count? We probably do. We can point. What I forgot to is you should always kind of prefix these by the module name that they're in, because they're kind of like global. Now we can say that plus plus equals the dev, and we can start filling out the device with, and again, my IntelliSense has taken a dump, so just need to temporarily bring this stuff in. How to imagine E having 17k viewers. Oh, you're talking about OTK's extra Emily. Right, let's copy this stuff over. Class code, subclass logger. The description can be this here. We want to set the bus, don't we? The function. Oh, we need the device number too. Let's get that guy in here. Device. All right, so we can just dump that into now in this log. And then we'll also dump at the end of the scan. PCI devices. Okay. I'm trying to get into the habit too of like prefixing logs with the module. Oh wait, we don't want the module name and the device name. What am I thinking about? It's just here. Yeah, that's fine. Okay. I implicit declaration of malloc. Did you mean calloc? I did. How nice of you to correct me. Did I copy? Previous declaration of type int. There we go. Compiler-driven development, yeah. I think I thought C was going to be a bit quicker for me to get used to, given the vast amount of languages that I've worked with over the years, but it's still tripping me up. It still hasn't kind of sunk in, but it will do eventually. At least I've got a handle on reading from memory mapped locations in memory. That is definitely a problematic area that I'm glad I'm past. The use of the volatile keyword. Oh, we want to save the address though, don't we? Do. Do I want to? Yeah, I'm not going to lose sleep on copying and pasting this. Screw it. So address will be offset. Offset is the register, so we won't have an offset. This is the base address. It's the MMO base into the higher half, and then a location of the bus device and function. And then I can apply offsets after to get into the registration registers, the registers for the PCI configuration. Okay, I think that's everything. Found 7 PCI devices, PCI initialized. Lovely. All right, so now we've got a bit of a map of our devices. And now what we can do, another thing too that I realized today is we're just dumping everything in the kernel. But when I say dumping everything in the kernel, for example, like we've got a terminal that runs in the kernel. But when we get the storage controller under control and we get user programs, I want to start moving the drivers into their own little modules that we load on kernel boot. And that will be a nice exercise on kind of warming ourselves up to the compilation and running of user mode programs. So I can just use the driver as like my first user level programs. And that will get us into the whole privilege stuff, right? It's like what privilege level or ring do these things then run in? So that'll be a nice little hump that we'll have to climb over. All right, so when we do the check function, when we create the PCI device, so this is all about parsing the tree right now. When do I want to then launch into spinning up the NVMe driver? I'm going to create a new folder in here and call it drivers. Then it can run Doom. Did you guys see the Doom running on a toothbrush today? This. I mean, if it's got a display, a colored display, and it's got some memory and a CPU, of course you're going to run Doom. But I'm thinking like Doom must have been written on an an x86 CPU, right? So is that what it's running on in a toothbrush? Is it really running that architecture for a damn toothbrush? That lovely playlist we had the other night. This is a bit too relaxing. There we go. Okay. I'm just gonna go fill up grab some water, guys. I'll be back in like 30 seconds. Whoops. Boom. It's Carmack's plan all along. It's kind of like the tire kicking exercise of every new device in the world. It's like, right, we built this device, can it run Doom? I mean, I think Doom's source code it was just C and assembly, I think. Linux Doom? Yeah, somebody emulates this code base. Like, you've got to handle the net, the sound, the graphics, and the inputs. Readme.asm, excuse me? Why am I in an assembly file for the readme? Anyway, Yeah, it'd be just interesting to know to what degree you have to emulate the Doom source code on a custom chip. All right. Okay. Procrastination time over. We are. Oh, we're going to move the PS2 to the driver folder and also going to create NVMe. All right, let's go. NVMe, bring it on. NVMe init. I'm probably going to bring in PCI here if I want the PCI device. Or do we? No, because if you've got multiple SSDs, we can for now. It's whatever. We'll just do the one, but obviously you can have multiple drives, and therefore we'll just have to work on. Oh no, I've changed my mind. We'll scan the PCI tree that we have. Yeah, we're going to start simple for sure. I'm desperately wanting to get to reading FAT32, and the reason for that being the initial file system is because the kernel, what we're building it in, is a FAT32 drive. So our image, if I go to our build files, build HDD, we're formatted as FAT32. So we've got a way here to compile programs and stuff files into that hard disk. So this is where we'll create some ELF files of some simple Hello World programs and then write them onto the hard disk. And then the kind of like the Hello World of reading FAT32 will be getting to that file, loading into memory and invoking it. So it will be nice to kind of then turn the terminal into a device map or a virtual file system, and then map that into the virtual file system and so on and so forth. So yeah, but it took us like 5 days to get the HPT timer up and running, and that wasn't that big. This whole storage controller, I think, is going to take me a couple of weeks. This being day one. So I'm giving myself mentally a couple of weeks to get this kind of bottomed out, given the time that I have after work and stuff like that. So yeah, NVMe init is going to init based on scanning the PCI list. Bring in PCI and then bring in the header. I was hoping it was going to be easier to access the disk. I didn't think we'd have to go through this elaborate controller interface. Okay. Oh, we need str as well. and then we'll plug that into the kernel. So this is the bit I want to change eventually. It's like hard coding this stuff into the kernel base is kind of meh. So we're going to want to like load drivers, look for driver IDs, that kind of thing. Load this driver in dynamically. So it's going to be after PCI. Okay. Pick the tires. Yep. All right, so we're here. So step one. Oh, hold on a second. I've just had a thought about. Let's go into the PCI. Let me just bring up this class code again. I think the device that we find is not the drive, it's the controller. So I'm wondering if when we start talking to the controller, do we then specify drive IDs? And I would be willing to put my money on that's how it works. The other option would be to be network only and PXE boot it. Yeah, I definitely, it's one of the another core driver that we want is the network driver. After storage will be network. And then after network, we'll do the Intel VGA chip. Because we want something better than software rendering. And then I'm really tempted to convince myself not to start thinking about a Windows UI because I love coding Windows UIs. It reminds me of my game dev days. And I've got, this whole model in my head of how to create windows and window message pumps and, a Windows API through the kernel, which would be fun, like pumping key presses down to Windows and that, just like how the Win32 API worked. Because what we don't have in this kernel base yet is we don't have any syscalls. I've not understood how syscalls work at all. But yeah, that whole, back in VB days, the old Win32 API.txt file, do you remember that living in the Windows setup since Windows 95? I bet it's still online. Win32 API.txt. Oh my god, it is. Here it is. I remember in my first, as a kid in high school, finding this. And you had MCI send string, finding out that this command could open the CD tray, and then writing viruses on my school network to just open all the computer's CD trays. I think it's what probably most people, as a kid, you think, what funny shit can I write? What can I impress people with? So you end up doing some silly stuff. But yeah, I remember scrolling this for hours and be thinking what on earth is, bit BLT? And I found all this stuff talking about brushes and pens and lines and rendering. All of this stuff here, I'd be like, oh my god, what is create bitmap? What is create palette, round rectangle? But it's kind of wild that all of that was contained in the GDI driver. Which, that's another idea there for another driver we could do for it eventually. Is like the windowing driver. that we boot into after the kernel could be our graphics device interface. GDI 64. Um, okay, so we're going to scan through the list. Let's see, struct, PCI device, find NVMe controller. PCI devices. I dev. No IntelliSense because VS Code is a big wiener. He had to go up on that like Phoebe, kicked her right out. Dude, I remember before I even understood how games were made that I had VB6 and I would initialize DirectX, load in a model file from some demo like 3D game dev site and render a flat plane and control this car in VB, thinking, oh my god, I found the way on how people make games. And I was, oh my god, it was such the height of like massive dopamine hits from coding. Like that thing kept my brain electrified for weeks. Like, I don't want to go to school, I just want to code, man. You know, you didn't want to sleep because you were just so excited about the stuff you were finding. All right, so we're looking for 0108. Class code 01, subclass 08. It's going to be a pointer to the device. Found it. It's going to return 0 if it didn't. Okay, somebody who's kind of done more C than I have, can you tell me why I just wouldn't use type def all the time and save me typing struct everywhere? Like, why can't I do this? Trick is to never let go of that excitement, discovering new things. You can let it mellow as you gain experience, but I think if it starts being a little excited, it's time to hang up my hat. Yeah, to be honest, this is what's got me into OS dev. So when we first implemented the PCI bus, I felt that massive burst of excitement knowing that I could see devices. Like that, those little moments were like little massive light bulbs inside of my head of like, oh my God, I'm doing this. I'm finally getting into something really cool, right? I'm scanning the motherboard and I can see the drives, I can see the controllers, right? And that was like a really exciting moment. I think the other big exciting moment was finishing the memory manager. That was a nice feeling knowing that we could just request physical memory. whenever I need it. The GDT and the IDT stuff I hated. I hated doing the APIC stuff. I get that they're easy now, but they were just so abstract when I started. Like someone said to me like, "Oh, the first thing you need to do is initialize the GDT." And in my world, I had no clue what the GDT was, why it existed, what it was used for, but you needed to initialize it as the very first thing. So it was like, okay, I'll go and initialize this thing, but I have no idea why, what it's giving me. So it felt horrible. But I already understand now how I need to go back and extend the entries in the GDT for purposes. Why was I gonna... Oh, that's right. When we turn on the cores and we start running user tasks or threads and processes, we need to extend the entries in the GDT to give different permissions on the memory. Three stars. Did you say something? Or did you try and link something? I think I've got hyperlinks turned off, so you might got taken out there. Oh, by the way, we've got a bot in the channel now. If anybody needs any commands adding, I can get stuff in there. You're linking to the Linux coding style thing as to why not to type def. Because, yeah, it was interesting how the more I researched it, people were saying, like, why wouldn't you type def? You get more control and less syntax over your structs. But looking at people's OSs, they're not type defing everything. And I'm like, why? So I'm kind of scared. I don't know enough. I need to. It's something I need to research and understand more in C to get why that is a problem. Anyway, let's call find enemy controller. Let's do a node check on this. I would use the null word like a proper. New. Okay. If we can't find controller not found. Well, yeah. What am I doing? Suggested parentheses around assignment uses a truth value. Excuse me. Oh. Oh, that error message had nothing to do with that. Hold on, I think I can permit you. I think I'm just getting used to my bot commands. Hold on. Hit permit. No. If you put a space in between like the HTTPS and try and sneak it through that way, that might help. Type defs are problematic because they do not properly hide the underlying type. You need need to know if the type def is the structure itself or a pointer to the structure. Interesting. Oh, someone's replied in my disk. My implementation is quite complete already and should get a few more features and bug fixes here and there over the next few days. You can have a look at my GitHub if you're interested. I'm still missing some kind of buffering for disk reads, but I should have time to do that this weekend. Okay. Well, I'm just gonna test the log, see if we get the. Alright, so I did find the device. Turn out over there. I'm wondering if that should be in PCI. It should. I need to. Is it Control P? It is. I need to get into the habit of using that more. It's faster than searching for my files now. Yeah, so we'll add this guy. And then what we just did in the NVMe here. Boop. Subclass. That's clever. Might not even be the bot. I think that's a Twitch setting. Where would I change this? I would change it in settings, channel, stream maybe. Content, community, moderation. Block links is now off. You should be able to link it now. Okay, find a device by its class and subclass code. That's in there, and then we'll just call this guy in the NVMe, which we don't even need here now. So OX01. I've got a feeling, and I'm not sure right now until we know more about it, but searching for just codes is probably not ideal. But again, don't know any better right now, so it doesn't matter. We can evolve as we find things out. Some reading for later. Yeah, perfect, thanks. There's a lot of crazy shit that happens in the Linux kernel too. So they use a lot of C, what are they called? They're not built-ins, they're like attributes of some kind. Like Linux has a really special attribute for defining IO memory. When I showed the OS Dev Discord that attribute stuff, they were like, that's cursed and you don't need that anymore. So I'm like, oh, okay. And I was kind of worried why that was in the Linux kernel, and I don't see it in other open source OSs. Linux developers are weird. You know, it gives me excitement to think that I'm at this point in my life where I used to think OS developers were gods. And anybody that could tell me that they were checking the Linux source code for anything, I'd be thinking, oh my God, you must be a wizard. And it's I still have to check myself when I think, oh my God, I'm actually someone now who is going into the Linux kernel and checking their source code to help me with my OS. Like just even that's happened in my life. I'm like, oh my God, I'm one of those magical wizards that I imagined. And the other crazy thing too is it's not just my perception, it is generally the perception of the industry. So I was in a stand up one morning and people were just like, oh, what did you get up to at the weekend? And everyone was just like, oh, I did this and I did that. And I was like, oh, yeah, I worked on my own OS. And immediately when they were like, wait, you're writing your own OS? And I'm like, yeah, I've just started tinkering with a 64-bit OS. And immediately people were like, dude, that's insane. Like, who are you? So it's an interesting perception. The Minix source? No. Um, is it this? Wait, what is this? Am I in the right repo here? Is this what you were talking to about? Sorry. Oh, PCI. Oh, this does look nice. I don't know why, but I always feel good when I can see good, like well formatted comments and tab spacing. It makes me feel like the developer like cared about their code, you know? So interesting. I'll have to take a look at that off stream. Linux runs on Intel's management engine on just every oh, when you say every chip, do you mean like any CPU? Holy moly, that's crazy. And how long's that been in development for? 2014? You can see some of the commit dates 7 years ago, 8 years ago. I'm so glad you've sent me that though, because that source code looks really nice to read. And the more, I think that's the thing that people should, when I got into the OS dev community, and people were just like, you need to read specs, you need to Google for stuff. And I wish somebody would just give me a nice list, like I've been recording in here in my links file. I'll put that Minx in here as well. Well, Minix, should I say. But yeah, there needs to be like a nice big book of references and examples and oh, it's been around since 1987. That's crazy. I've accepted, by the way, that this 64-bit OS project is probably like a life's worth of work. Like what I'm doing now is probably going to be here for the next decade, and I'm okay with that. If this thing is still in dev in the next 10 years, fine. It is what it is. It's my lifelong hobby, you know. I'll put it down in the summer when I do summer stuff, and then I'll pick it back up in the winter, that kind of thing. Plan 9. Dude, you got the links, dude. Let's just drop that in here. Plan 9. Boop. So this guy. Goodness, libregexpression. They've even wrote their own regexpression engine. Wow. Games. Just looking what their user programs look like. Says fatal, init, disk init, get window, free image, alloc image. Add disk. Oh, disk as in. Okay. No, that's cool. Thanks for that. Made by the guys from Unix and Go. Oh, really? libauth. Ooh. That's the first open source OS I've seen that's got auth code in there. Like user accounts, maybe. libgeometry, HTTP library. What? Okay, I just want to see if they've got anything to do with random. True rend. Okay, I'm getting losing myself here. I love finding repos like that. The White House is molding watching your stream. Yeah, absolutely. For you to ask that question, you might have some Rust experience. Can Rust, or does anybody know this? Can Rust generate a non-standard library C compiled ELF image? Which ultimately is me asking you, can you write a kernel in Rust? Does anybody know that? Absolutely. How does that work though? Because Rust has got its own um, memory manager. So when it compiles, does it like throw a load of shit in your elf image for you? Redux OS is in Rust. Bypass the standard load and generate the image, then jump directly into it from the bootloader. God, you guys have got like all this awesome knowledge. Like writing an OS in Rust, isn't that like amazing? Like, why isn't this like the new, you know, everyone rushing to make a Rust-based OS, given that it's memory safe? I don't know. That throws up so many things in my head. Like, I need to understand how that's architected. The source code's on GitLab. I don't think I'm in the right thing there. Bootloader. Kernel. There it is. Source. ACPI. Okay, let's just have a look what this looks like. I've never really looked at Rust code. That's not bad. Can we go dark mode, by the way? My eyes are burning. Probably not. OSDev Wiki has a section on Rust. Gamozo streams were so cool. I'm guessing somebody used to stream coding this. Is that what that is? Yeah, I'm going to research that because I still can't wrap my head around how if you're in Rust as the language and you're using memory allocations that are memory safe, which is the strength of Rust. Where is that library? And how is it given to you in the microkernel? Unsafe locked allocator allocate map containing address physical. Oh my, that looks fun. It looks like a functional coding block. Given that the function there is a match, I'm guessing it's kind of like functional. All right, we'll save that one as well. Oh man, we got lots of cool homework. Jesus. What are you doing to me, guys? Next stream will be I've decided to ditch my C-based operating system, and we're now doing this in Rust. And then we'll get like 100 viewers per stream because people are like, oh my god, what the fuck? Rust OS, let's go. Like what I'm doing has been done like for 20 years, rinse and repeat. Um, all right, so no links. We got it. Oh, you're an OS dev? Oh, right. So you live in that space. I've always been a business domain dev. Probably, yeah, I've never done low level stuff. It's always game dev, DirectX, OpenGL, um, Windows programming, desktop apps, web dev, tons of web dev, which is like most people, right? But that was actually so one of the things that got me into wanting to write my own OS, right, was I hated not knowing how device drivers were written. I'm like, when I see a device driver, like, what is it? What's in there? What is someone writing to make that thing a device driver? And how is that clicking into an operating system? Um, and I wanted to know that. I mean, it's really obvious now, knowing what that is, but it's cool, you know? I'm going to find it really cool to actually load a driver into the kernel. That'll be satisfying, like plugin architecture. Like, I definitely want to do that. I want to rip out the terminal. I want to rip out the PS2 driver and this NVMe driver. Oh God, I'm getting excited now because I'm just imagining my OS booting up and it's like loading drivers, found these drivers, initializing them, drivers now online, and then, them setting up some kind of event system going through the kernel that's specific to a driver, and they're passing event types to other things. Oh, that sounds juicy. That sounds fun. That sounds more fun than probably even getting to the scheduler or like the core scheduler. Why does assembly scare you? A lot of people like say, "Oh God, assembly," but to me, it's just like dumb. Like there's nothing complex about an instruction sheet. Like do this thing, now do this next thing, now do this, now do that, now do this, now do that. Bring two worlds together, event sourcing and CQRS. See, I know what that is. Command query responsibility segregation. See? From the business world. But all of those concepts and those design patterns, if I can call them design patterns, yeah, those kick in when kind of like getting into that plugin architecture thing and that message pumping stuff. I've seen it in the Lyra OS actually, which is again, it's my main source of reference, and they are using messages per core. They're pumping messages onto the cores for the message queue. Been doing assembly since the Z80, dude. Old school. How very Erlang? Oh man. We have a distributed Erlang cluster at work that handle it. You wouldn't believe how large the boxes are. The amount of traffic that those things handle is insane. Like distributed Erlang, conceptually how that hangs together with like its message boxes and constantly sharing processor state or process state across the network. It's kind of amazing. Still maintaining React? Yes. Actively maintaining React and working with it a lot. I've got a project actually coming up that's going to be plugging some stuff into React, which is, again, it's another interesting piece of tech because if you've never heard what a CRDT is, it's an interesting mind pattern to look up and learn. So CRDTs are like, I can't remember what they stand for. Some CRDT. Let me just get it. It's a math concept, a conflict-free replicated data type. So it's a distributed computing concept, and React loves CRDTs. It's how it scales. So the data types that we set up in React are all CRDTs. And it makes it a really interesting database to use because you're like, what's a CRDT? And then when you understand what those things do and how you use them, you're like, oh, this is magical. Like, we understand now how this thing scales. Um, but yes, CRDT is a concept, like even just the high level concept of CRDT. It's a really good thing to implant in your brain. If you don't know it, you should definitely go and learn it. Uh, Maybe it's because I did not know what projects about it. Programmed in Arduino, C++. I'm assuming without saying the name though, do you know where I work, Reb? When you said you guys still maintaining, I assume you know where I work. The reason I don't like saying where I work is because it's kind of taboo. So I usually just keep the name out conversations. And it's not good to tell people either because when people know that you work there, you get hounded by people, not developers, but weird hackers and people trying to do nefarious things with the company. Like we have an entire infosec team that deal with people hacking us every single day. And more weirdly is that we have people that scrape data from us who are now living as millionaires. And when we shut those kind of people down, we immediately overnight shut off their money source, and that upsets people like you wouldn't believe. So I don't try to advertise where I work, knowing there are like things could happen to people that are very upset about what we do by taking away people's money. Rightly so, though. Like they're scraping data and making lives off illegal activity, but um, you nearly work there too. Interesting. It's a super interesting place. We've just taken on Google Cloud Platform, and we're trying to move things into the Google Cloud. Another super interesting thing we're doing too is we're fully on board with LLMs. So we have contracts with Microsoft and Google, and we can run the ChatGPT LLM on our own hardware. So we've got access to all the big LLMs, and we have an innovations team that are configuring on-prem LLMs, the ChatGPT models, to absorb things like process documents and um, software documentation. That new people joining the company can have a discussion with a chatbot to learn what's going on with software processes or the documentation around services and things like that, which is exciting. That's stuff that's coming on the horizon soon. But I've already seen like previews of that stuff working, and it's super exciting. Right, back to this is ultimate procrastination, and I'm happy to do it because this NVMe is scaring me. But let's try and do at least something with this driver. Let's try and say hello. I'd be happy if we say hello to it today. That would be nice. Statements like this don't do me any favors. Its registers are available through bar 0. It's bar 0. It's the concept in the PCI page. What's bar? It is. Wait, is this a different memory space to the devices? Oh no, it is, isn't it? Because the things that we're talking to are the PCI configuration memory space. The bar is something we have not yet addressed. Yes. Oh, okay. Right. No, I don't mind talking about it. It's absolutely fine. I find it all fascinating. I love techie talks. But to wind back a bit, so yeah, getting a message pumping kind of system between drivers and through the scheduler and through user space programs, I'm going to find that really interesting and very exciting to work on. I'll be pleased to get like syscalls into place as well and learning about the different ring privilege levels. But this, we've got all the time in the world. This thing's like a decade's worth of project. I'm hoping for the rest, like sometime this year, we'll have at least storage, networking, maybe some UI. Like that's reasonable. Like network doesn't seem too bad. That would be an exciting thing to work on. You know, Ethernet frames, DNS, implementing the HTTP protocol. That would be super fun. Even doing an SSL handshake, which actually then drives out cryptography. So that'll be a bit of a pain. But at least having a HTTP protocol will be fun. Like I think one of the goals I set out for this OS project was it performing a handshake with a Twitter account and posting a tweet like, "Boom, hi, I'm tweeting at you from Blur OS," and then that would be like, "Oh my God, look at that baby go!" You know, my little OS is talking to the world. That would be cool. All right, so the bar. How do we get to the bar? Here's a layout of the BIST register. Bridge control, BIST. Oh, BIST. That's nothing to do with what? Oh, base address 1, 0 and 1. There we go. So it's in the configuration table. Well, that's fine. We can grab those. That's an easy job. We probably need to because that's where we're going to access the devices. Shall we just expose those addresses then and pass those to the NVMe? I'm guessing we do. Let's do that. Let's put it's a 32-bit address, but we'll be putting that into VMM space, so that'll become a 64-bit address. I'm guessing bar 1 as well. Ah, Control P. There we go. Sick of eyeballing the files now because I'm scrolling in the list, so I need to start using Control P. Who's up for installing NeoVim and learning Vim and becoming one of the cool kids? Oh yeah, DHH announced that his company's doing that, isn't he? There's an IDE that I saw. Oh, what's his name? There's a streamer coder on Twitch who writes his own games, and he has his own language even and compiler. Can't think of his name or the game names. But he had this person. I'm hoping you know who I'm talking about. Has a really nice IDE, and I don't know what it is. It didn't look Vimy, but it looked very terminalish. But it had everything like switching between files, terminal commands. Jonathan Blow, that's the guy. Yeah, he streams on Twitch, doesn't he? So I'd be nice to know what his IDE is. Or is he using Emacs? Interesting. Yeah, that looks like a nice IDE, to be honest. Let's get these functions around. These are super easy. Reading from a register. Offset 10 and 14. It's a 32-bit read. Get the address first. Excuse me. So PCI memory. IntelliSense, where are you? Oh, it wants the bus. Oh, right. So there's a different bar address for each device. Okay, that's fine then. I can do that. Wouldn't I just... Oh, what am I doing? I'm going about this the wrong way. We're going to put that in here. And we'll grab that on PCI parsing load. So this here should do. Bus device function offset offset 10 size is a 32-bit value, so that's 4 bytes. And then the bar 1 address will be 14. However, we do need to put that into virtual address space. Okay. A lot of game does use 4-coder. love for Notepad++. I have a thing for Notepad++ at work because it's fast. It's a very Windows native app, not like some shitty Electron JS based thing. Like it's faster than VS Code. It starts up like sub-second. It's super fast. It's got tons of features. I used to be into Sublime, but it had that same sluggish feeling that I get with VS Code, and Notepad++ comes out on top. So the more snappier an app is, it's more likely to keep me interested, which is why I love native Windows apps rather than Electron JS apps. Right, anything else we need on here? Let's just have a gander. You know, status, memory limit, prefetch base limit, IO limit. Might need these, right? Maybe. We'll see. We're in discovery phase right now, so we're just growing things as we learn them. All right, so that comes in the PCI structure. So in the NVM driver, the question is which one's being ported to Blur OS? Very true. I'm not sure if you guys have been here before when you've heard me say I want to have the experience of creating my own programming language for the OS. And I'll tell you why, as insane as that sounds. Hold on, I'm just modifying my TV. So first reasons is what does it take to write a programming language? Second reason is I want to really truly know how to write my own ELF image with instruction codes and opcodes and stuff. And I want to go through that process of at least doing like hello world. This is my language. This is my hello world compiler. And we came up with the name Sea Lily. And it's going to be a mix of C and Go, grammar wise. Save yourselves some sanity and use QBE. And what's QBE? Well, the thing I want it to be like more like Go than anything, but I want some class syntax put back in, but no like no multi inheritance or crazy shit like that. But just at least some class syntax instead of repeating um, type names on function signatures and stuff like that. Building your own IDE in browser and text editor, yeah, that's a crazy. Like, I think the most scary thing of that would be your own browser. Like, imagine just making a CSS engine, given knowing how brittle that thing is. Scary as hell. Yeah, I don't think I'd go that far. Oh, it's a compiler backend, I see. And I'm guessing it lets you just get up and running with your language grammar. And it probably tokenizes for you and stuff like that. Serenity OS dude did it? Oh my god, no. like the box model, knowing that you have to support floats and oh, dude, makes me shiver thinking about all that crap. You'd have to go through all the specs starting from HTML 1.0. Absolute nightmare. You'd probably be there a year just working on that or planning it. I'm going to dump out these addresses because I like seeing addresses. I don't know why, but once I can see like the addresses in memory, I'm like, oh, that's interesting. That looks like an interesting location. What's nice about having two addresses too is that if they look quite closely related, then you kind of know you're in the right thing or on the right place. So bar 0 looks sane, bar 1 does not. But we might not even use bar 1. I just put it in there in case, but it doesn't look like it's valid. Maybe it's not valid for this device, but it is for others. Who knows? Okay. Should be 64 memory I/O. So register accessible through bar 0. Question though. Once you've address and size of the bar, let me just read this here. Base address registers. We might need more shit from that base table. Typically, memory address bars need to be located in physical RAM, while I/O bars can reside at any memory address, even beyond physical. To distinguish between them, you can check the value of the lowest bit. The following table describes the two types of bars. Oh, bit 0, always 0. Bits 1 to 2 is the type. Bit 3 is prefetchable. Bits 4 to 31 is 16 by a line base address. Oh. That specifically says base address. Um, the type field of the memory space bar layout specifies the size of the base register and where in memory it can be mapped. If it has a value of 0, then the base register is 32 bits wide and mapped anywhere in the 32-bit memory space. 2 means a register is 64-bit wide and can be mapped anywhere in 64 memory space. When a base address register is marked as prefetchable, it means that the region does not have read side effects. Reading from that memory range doesn't change any state. It's allowed for the CPU to cache loads from that memory region and read in bursts. If you are using paging and want maximum performance, you should map prefetchable MMIO registers as write through instead of uncacheable. I'm guessing that is a page table setup flag. On x86 frame buffers are the exception, they should almost be mapped to write combining. When you want to retrieve the actual base address of a bar, be sure to mask the lower bits. For 16-bit memory space bars, you calculate bar X and that mapping, or the mask. Okay. For 32-bit memory space bars, you calculate and mask that. 64 bars, IO space bars. Interesting. Before attempting to read the information at the bar, make sure to disable both IO and memory decode in the command byte. Disable both IO and memory decode in the command byte. Oh, this guy? You can restore the original value after completing the bar info read. This is needed as some devices are known to decode the write of all ones to the register as an unintended access. To determine the amount of address space needed by a PCI device, you must save the original value of the bar, write a value of all ones to the register, then read it back. The amount of memory can then be determined by masking the bits, performing a bitwise, and incrementing the value by 1. The original value of the bar should be restored. Jesus, all of that just to get an address? Holy. I mean, fine, but it's, a bit of a ceremony step to. It is what it is. We shall implement it. It's fine. Straightforward. Everything's at hand. Yeah, I'm just kind of like getting over the mental of, oh, I need to fuck about with it first. So it's not that bad, really. So how did it say? All right, got a shopping list of things to do here. So we've got to do shit with the command register. Boop. And then we've got some masking to do, but how do I know? Here, the type field of the memory space bar layout specifies the size of the base register in where memory. As a value of 0, the type field, the memory space bar. Wait, memory space? Memory space bar? IO base, memory base. I'm guessing it means this. Sorry, wrong table. Shit. Idiot. IO base, limit, memory base. PCI specifications at the PCI 6 site. There's also PCI.02. Oh, I think there's links to those. I mean, this is fine. I think what we have here. Um, I've just got to be careful here because some of these header types are specific to bridges. Oh, I need to know what the header type is before I can pass the table. Oh, okay then. Header type. Um, I'm guessing that's common across all the tables. At register 3. Yep. So there's books on PCI. Oh my god, what are we getting ourselves into, guys? So they're going to get removed, I'm sure, or at least fixed at some point. But we first need to grab that header type, which I think, yeah, we're using that here. Check device. Check function. Just pass that in because I don't want to reread that. I think this needs going in here. Might not. So, to put it in. It's just stuff we've passed anyway. Um, right. Stack of specs and data sheets, and you can build anything. Yeah, it's one thing I'm learning about this whole OS dev process is you find a spec or a PDF, and pretty much you've got to learn how to know what's applicable to you and what isn't. And I'm starting to see patterns in uh, device behavior, like memory aligned, you know, don't read across the boundary of 32 bits here or you'll blow up. So scanning a dock, and if it says like, these registers are aligned at the 32-bit boundary, I instantly now understand what that means. Yeah, I'll probably have a scan over those. Let me just write that down though. Let's put it in the links. I'll put it in there for now. I'll have a scan for that. Ta-da! I had no idea that PCI was this crazy. And it's not, the word crazy is not the right word. I didn't realize it was so in depth. Um, which one do we choose? All right, let's put that in links. Let's make put that in quotes so I understand that's a search term. Cool. All right. What time are we on? 11:30. Okay. PCI Express 8. Cool. Okay, so that header type's being captured on the PCI struct. So what I can do now at least is print that out and just see what header type we're dealing with. Do hexadecimal. And then I'll understand which table to look at, and then I can do the base address stuff or the address manipulation things. I'm pleased actually knowing that this has all been quite discoverable so far. So there's no like hard blocking, oh my god, I'm missing information, you know? So it says header type 0. So header type 0 in PCI, this guy. Oh my god. I'm working through this, the more things are clicking about how this address space is set up. Like it wasn't that obvious reading the document head to toe what was going on. Like you could create a diagram that maps this out perfectly Like you could just say, right, here's a struct. There's a value on here that points to and represents this block, and someone could create a block diagram showing that relationship. And I'm just asking for too much because that's probably super obvious to an experienced OS dev reading this. And once you know, right? I wonder if ChatGPT could parse this and turn it into a diagram. That would be insane. Should we give it a go? Parse this memory layout. Hmm. It can't parse external websites. No. You know what we're going to do now? I don't know if it'll let me paste this amount of tokens in there. Oh, I don't need the class codes, do I? Put in first. Grab that. Boom. Disgusting. No. Generating image. I've never seen it generate a good diagram based off random textual things. It can do sequence diagrams pretty well. This will be insane if it gets it right. Like it's understood here what the major components are, so it might do. Oh no. No, that's not going to work, ChatGPT. Jesus. Come on, dude. Let's downvote that. That's the only way we've got to tell OpenAI AI that the model needs tuning. It's through those upvotes and downvotes. Okay, never mind. It's fine. I've got the picture in my head now, and it's all good. It's kind of scary though that if you're in this mode of dealing with bridges, you've got to do table parsing a little bit differently. So we have our base addresses at these locations. We have card bus, system ID, subsystem expansion ROM address. But if we only have the base addresses at those locations, we're missing some stuff there. Yeah, how do we get the memory space and the I/O space? oh, is it this? You want to retrieve the actual base address of a bar, be sure to mask the lower bits for 16-bit space bars. And then the IO space bars. Oh, and before we do that, we need to set the command status. So set the command, do the read, put the command back. Code. Set the command status. Get the command status. Read bar addresses. Fill command status. So you have both type 0 and type 1 configurations. Have a set of common registers in the PCI compatible region 0 to 3FH. I don't know what that means. You have type both 0 and 1. How do I have both types? When the header type tells me it's 0. So the header type tells me it's 0, and then I have this table. How does that tell me that I have more than this? If I miss something? Capabilities pointer maybe? Type 1, which is this, is a PCI to PCI bridge. What did we actually get in the device dump, actually? We got a host bridge. Is it that we need to inspect? But that can't be there for no reason, right? What's the host bridge? It's one of them. ISA bridge. Let's put the ISA bridge and the host bridge. Man, I need to take out that PMM. There we go. It's a host controller chip. So when you've read these bridges, I'm guessing they're going to give you header types of these things. But how does that help you getting access to a device's bar? So like we get the NVMe controller, that device configuration is telling me that it has a header type of 0. So how is it this here? I'm guessing it's this. But I think what's missing from that statement is how do I know if I'm 64-bit, 32-bit, or 16-bit? Um, do. device, maybe? PCI? Legacy, scan, dispatch drivers. Terrible way to do this. PCI initialize, scan buses, enable IRQ, set mask, get bar for a device index. So is this implementing that? Let's see, index is 5, return result, PCI bar result 0. It's doing a read to get base low size from register 10 plus index though. Let's just cross-reference that with the table. 10, no, it's, yeah, 10's here. Index 0, so bar 0. Size of int 32, 32-bit read, boom, taking the register. And then it's base low, read, the offset, write, read, write. D device. Is that? The address size for the base of register for an NVMe atomic device, typically 64-bit memory, accessible through bar 0. In the context of controllers found as PCI, the register access through bar 0, which should be a 64-bit memory I/O. This means that the bar for NVMe device is set up to handle 64-bit memory addresses. Is that a ChatGPT response? If base low and 1 do this, else do this shizzle. Is MMIO baseline. I wonder what the why they're testing that first bit. What's on the first bit? Space. Command register though. I don't think that's it. So you're starting at 10 and you're saying the base low is that read at register 10, which is the base address number. Header type, completion best register, header type. Bit 0 is always 0. Memory space bar, IO space bar. Wait, I think I remember reading something about the first bit. Oh, it's in a document about PCIe and NVMe. Okay. there. Memory address bars need to be located physical RAM where IO space bars comes out at memory address even beyond physical memory. Oh, I see. So a bar, an actual bar is abstract. Bar address is abstract. So that bar resolves into a type, and it's either a memory space type or an IO space type. Is that right? You're a memory space if your first bit is 0. You're an IO space if your bit is 1. Why do we even care about that? Well, it determines where the aligned base address is. Okay, it's kind of making more sense now. It's it ties up as to why they're doing a bit check here. So that there is dealing with a memory space bar, and this else block is dealing with an IO space bar, which is why they've flipped this is MMIO to true to indicate this. Open pull request. Add comments, please. Close pull request. Yeah, I get it now. We get it. And now that we get that, we can execute this, which is what this is doing. So once we understand what kind of bar they're using, they're setting the base and the length. And the same here. What's interesting though is they're not writing the command register and restoring it. Or are they? I can't quite understand what this write's doing here. Why size low? It's reading from the same address. Base low, size low, right, offset D. It's a 32-bit read. Get that offset at 10. Why? That's such a weird. I've not seen why they're doing this in the doc. Read from the bar address register, right? So it's reading that memory location. And then it writes, turning things off. And then it reads again on the same location and calls that size low, and then writes back in there the first red value. But the instructions below says that you should be writing on command. So why are they writing to bar? It might be a bug. It might be a bug. I need to check that with the maintainers on Discord. Because that does not correspond to this command location. Okay, so I think we can implement this now that I understand what's happening. And we can do a similar thing here, as in they've put it in a struct though, interestingly. Baseline is oh okay, they're just representing the bar type. I guess that's not a bad idea. Um, all right, I get it. I understand now. It just took some grasping of what was happening, but I need to double check this with the maintainers after the stream. Okay, it's 10 to 12. I think I've run out of time, but oh man, we've kind of definitely expanded my expectation of what we're dealing with here. I'm glad I've given myself a couple of weeks to get through this, so there's no disappointment. I think a couple of weeks is still comfortable given the size of the documentation and the size of the code bases that are performing this stuff. But oh my god, I just really, really want to read from a disk. Like I cannot wait to get to a point where I'm reading some bytes from a disk and I can see that FAT32 table telling me that there's files there. No, it's fine. The chat was amazing today. I love the discourse that we had. Um, and I'm glad that you guys actually helped me pointing me to stuff. So I've got lots of new references to check and I need to check the specs, but I don't like checking specs on when I'm streaming mostly because I can sit there for 20 minutes reading a PDF and I don't know if people are going to find that entertaining or not. But so I kind of like doing some of the reading offline so I can just focus on coming to a stream with the answers and the implementation, which is what people really want to see, right? They're like, okay, how did he do that PCI bus scan? And they just want to go to that place in the stream and go, okay, that's how he did it. Um, but yeah, narrowing noise down is the thing that's most helpful, I think. I think that's what puts me off going towards a spec. So I like staying on the OS Dev wiki before progressing to a spec because I know that once I land in a spec, I've got the hard task of um, discerning information. But I'm super pleased at seeing this construct here and understanding what these bars are now. So again, the documentation here could have just been a bit nicer about these are bar types, you know. But yeah, thank you guys. My streams are a bit random at the moment because I'm back to work. It depends on how busy my work days have been. But if I'm not burnt out by what I've done in the day, if I've had an easy day, then I'll probably stream in the evenings. But I definitely try to stream every other day minimum. But streaming like consecutive days just depends on how I'm feeling energy wise. So I don't want to get too burned out for both work and hobby coding. So worst case, I'll stream on the weekend. Best case, I'll stream tomorrow. So yeah, thank you so much for your help, guys. And I will see you tomorrow or weekend or whenever I see you over again. Thanks for all your help and have a good evening.